Today we will be going over zero and negative exponents. We will simplify monomials using the power of power law of exponents. When a term is raised to the zero exponent, it always equals 1 when simplified. So what we're saying is no matter what the value was originally, what variable we use, if it is raised to the power of 0, it will always equal a value 1. When a term is raised to a negative exponent and simplified, the resulting term is a multiplicated inverse of a base raised to the positive power. What this means is if I have some number a, its multiplicative inverse is what number it could be multiplied by to equal 1. So through multiplication, that's usually 1 over that number. Just to write that down, a to the power of negative 1 would then equal one over a. Now to show the power to 0 rule, if I were to expand out x to the power of 6, both on the top and the bottom of my fraction, I would have a situation where I can show each one of these canceling out, each one of these becoming a value of 1, which then would leave me with 1. All of them cancel out in the sense that they become a value of 1 multiplied, ending up with 1. With our negative exponent, a nicer view of it, we have a situation where we have x to the power of 4 and x to the power of 5. If we follow the same step of canceling out, this example shows that we have what is left of 1 over x. If we follow the quotient power rule, we would have x to the power of 4 over x to the power of 5, which would have our x variable, our top exponent, minus our bottom exponent for the same variable base. Now this becomes x to the power of negative 1, which we already showed equals 1 over x. So to keep this simplified, whenever you have a negative exponent for a base, you will put it to the opposite of the division. So if it were at the bottom for my negative exponent, I would move it up to the top. Some examples. C to the power of negative 2 is just a negative exponent, which means I can simplify it by doing the multiplicative inverse and taking my negative value and turning it positive. So the simplified version of c to the negative 2 power is 1 over c to the power of 2. This one works with the rule the exponent only affects m, so 5 would still stay at the top of my fraction, whereas m changes to its multiplicative inverse, and the exponent becomes positive. Now to show this fully out, whenever I move the m to its other form, it would be 5 times 1 over m cubed. But anytime that you're multiplying a whole number by a fraction, you multiply to the top. 5 times 1 cleans up to just be 5. So that's why we simply just write what is not changing still at the top and everything else to the bottom. Number 3 example shows that we are actually affecting the 5 as well as the m. So if we wanted to real quickly, we could change it to where it affects both, leaving it as a positive. I'm sorry, leaving it to where the exponent affects both. Now we can clean it up some. We know we're still going to have 1 on the top. 5 to the power of 3 is 125. And then we'll have m to the power of 3. This is following our power of powers rule, which is seen in an earlier video. Now moving to some where we deal with the exponent 0. Following the powers of powers rule means that we multiply the number on the outside into every exponent for each base on the inside. Now we know that multiplying 0 times any number will give us 0, which shows that all of these would be 0. And we just learned that anytime we have an exponent of 0 equals 1. So instead of having to write this out for every single one and writing their new exponent, we should know that anytime everything is brought to the power of 0, the value is 1. Number 5 combines our negative exponent and our 0 rule. If we eliminate the bottom, because this value is 1, we'll get n to the power of negative 2. Then we can affect the negative exponent rule, which will give us 1 over n to the power of 2 as our answer. Our last example. We can do this different ways, but I'm going to follow it from the steps that I've already taught y'all in that order, where we will subtract the exponents using the quotient power rule. In this case, we would have negative 4 minus a negative 6. Minus a negative is just adding, so we end up with a squared. Now you could have gone through this where we switch a to the power of negative 4 and a to the power of negative 6 on the opposite using the multiple inverse rule. But in this case, just using the earlier rule of our quotient power rule gives us our answer. Now to box them all in again, to finish up our video.